All right, so yesterday, we worked on lessons 24 and 25. I'll remember that. And we took a little detour. We had been comparing fractions with lots of different strategies that we had on the board. And then all of a sudden, yesterday, I go and change it on you, and we stop and practice. What did we do yesterday? What were we? We were changing something back and forth. What were we doing? Yeah.
Never mind. I thought of it.
Somebody help him out. What were we doing yesterday? Changing what to what? Yeah.
We're changing improper fractions to like 1 and 1/2.
What is that called when it's like two different things put together? Think about when you, a mixed number. It's kind of a mixture. It's a mixture of a whole number and a fraction together. And we'll hear that a lot, so we'll get that name. So we were going from improper fractions to mixed numbers, and then mixed numbers to improper fractions, and we practiced both ways. I cannot remember if I said this to you at the end of yesterday. I think I did. End of math. That after learning so many new things, that we were going to kind of pause today. Did we talk about this? We did? Okay. I think I told you because we were not going to take the exit ticket yesterday, and we're going to take them today. 24 and 25, and they're both short. But they're going to have you practice going from an improper fraction to a mixed number, or a mixed number to an improper fraction. Okay? So I just didn't feel good about just jumping into the next thing, because the very next lesson that we do is something totally different. But one of the steps in that thing that's different is changing mixed numbers to improper fractions or improper fractions to mixed numbers. It's one of the steps instead of being the main thing we're talking about. So I wanted you to become more comfortable with those. Plus, this is a good day to also practice Steal It and Hide It and Heart Method, just to have a little, not to forget those. Okay? So we're going to practice all 4 of those kind of newer things today, just a little bit. All right. I'm just going to jump in here with we're not going to really do some review problems to get us, okay. I don't know where she left me. I just want a whiteboard. Is this throwaway stuff? I guess it is. But like, how much? How long am I going to, oh, there, okay. I thought I was going to be here a while.
Yeah.
All right. So,
Wait, so all of that's going to be there?
We're just going to do a few practice problems to get us warmed up, and then we'll do a few of each kind, and then we're going to practice in a few different ways today. All right, so let's reach on back to the heart method and the Steal It and Hide It method, okay, of comparing fractions. You use those two things to look at two fractions and go, hey, this one's larger or this one's smaller. Okay, that's what those are for. So if we had these two fractions, 6/8 and 3/5. And if I asked you to use the Steal It and Hide It method, if I said, use that method because I want you to practice it, jump in there and try to do that. See what you remember. Remember, there was two fractions that lived next door to each other in fraction land. They didn't get along. If you've got it, just hold on just a second so your arm doesn't fall off. The arms. So using Steal It and Hide It, keep going if you're not quite finished. Using Steal It and Hide It, Bailey, what new fractions did you come up with? Or actually, let's back up. What did you do to this side?
I did 8 times 5 and 6 times 5.
Okay, so you basically stole this denominator, brought it over here, and we multiplied by 5 in the numerator and the denominator. The eighths stole the fifths, brought them over here, and then hid it in the attic. Remember, that's how it got its name, steal it and hide it. Okay, so what did we do to the other side, Kennedy? What did we do over here? We grabbed that 8, didn't we? Grabbed the eighth, brought it over here, and hid it in the attic. In other words, we multiplied the numerator and the denominator by that. So each side is getting multiplied by the opposite side, whatever the denominator is. And we talked that day that because we're multiplying the top and the bottom, the numerator and the denominator, by the same number, all we're doing is creating an equivalent fraction. But look at the two bottom. Do you catch that this is 5 times 8 and this is 5 times 8? Okay? That you're creating that common denominator, which makes it very easy to compare. Okay? So what is our new fraction, Charlotte, on this side? 30 40ths. Good. And our new fraction on this side, after we do the multiplication, is what?
24 40.
Yeah, 24 40ths. And so, yes, they do start looking like they have larger numbers, but really doesn't matter. The important part is that they have the same denominator. Because now I can look at that and go, oh, all the pieces are the same size. They're all 40ths. Which one has more? Valerie, which of these has more? 30 40ths or 24 40ths? Yeah, 30 40ths. So if that's the case, then that's also the case. All right. No problem remembering that. You guys did a good job with that. Okay. So that is our steal it and hide it. Let's just do one more of those. Then we'll move on to the heart method. Okay. What if we have this kind of fraction? We've got 8 fifths, 9 sixths. What are those types of fractions? Look at both of them real quick. What's their names?
Improper.
This is improper fractions. Does this still work with improper fractions? Yeah, it does. We saw that the other day too. All right, go ahead and use steal it and hide it one more time, and let's work this out. Okay. Yeah, sometimes I like it. All right, Caleb, what would we do first?
We would multiply 8 fifths by 6.
Okay, both. I like how you named the whole fraction because we need to do the top and the bottom, numerator, denominator. So what's the whole new fraction that created?
48 30ths.
48 30ths. Okay. What about Ishmael, this side? What do we do to this side? Okay. Since the 5 is the denominator here, we're going to multiply both the numerator and denominator by 5. And what's the new fraction you got there? 45 30ths. Okay. So which one, Jayla, which one of these is largest? 48 30ths or 45 30ths? 48 30ths. So that makes 8 fifths larger. Okay. All right, this is a pretty simple method. It's just an easy way of creating the same denominator. That's what we're after. Yeah.
I feel like with improper fractions, I feel like they'll always be favored with this method. Yeah.
Well, they're both improper though, so it's like which improper fraction is the largest, you know? So sometimes you got to figure that out. Okay. All right, we're going to switch to the heart method. So, So 3/4 and 7/8. If you were trying to figure out which of these was largest using the heart method, okay. Just gotta remember this answer lands here, so you probably want to start the line right on there. This answer's gonna land. This time when you multiply, you're not coming up with an entire fraction, you're just creating a number, but that number leads you to know which side is largest. And we said the trickiest part of this is getting your lines correct, making sure they go to the right spot. So I saw something in second period that I'm going to share with you because sometimes, I pick up new ideas along the way. All right. Sometimes teachers, I say sometimes, really all the time, teachers share ideas with each other because it's like, hey, this worked really well. Really? Let me try it. And so I pick up things from sometimes Miss Terry because she goes in a lot of different math classrooms and sees a lot of things. She especially sees things in 5th grade that she'll share with me because she knows that that's where you're headed. Okay? All right, with heart method, okay, help me out here. Alexander, the 4 is going to go to the what? Yeah, that line's going to come around. And what is 4 times 7, everybody?
28.
28. All right, Martin, the 8 is going to go to the 3. Okay, and 8 times 3, everybody?
24.
24. And we obviously know that 28 is larger than 24, and so 7/8 is larger than 3/4. Now, I want to show you one thing right quick, and you might decide to do this. I'll just reuse that. It was 3/4 and what, 7/8? No. Yeah. Okay. So Miss Terry, sharing an idea. And if you like the heart method, but the hardest thing for you is to keep your lines, it's just hard for you to do that. This is what she showed us that made it simpler. She just went like this. You see, when I draw that heart line, I want my answer to stay over here. Well, this arrow is keeping it over here, right?
Yeah.
And that heart line is keeping the answer over here. Well, this arrow is keeping it over here. And she just wrote the answer right here. I was just curving it down with the heart and putting it right there. If you like making that heart, make that heart. But if you would rather do this because it's easier to draw because you're having trouble drawing those heart lines, if that's your big hang up, that's then do it like that. Okay? Because you're landing on the correct side of the fractions either way. Okay? All right. It just doesn't look like a cute little heart. It doesn't have a cute little name. But we could.
It looks like an X though.
Yeah. All right. Let me give you one more to do the heart method with. Let me jump up there. Okay. 7/5 and 10/8. All right. Use the heart method one more time, or if you like those arrows better, that's fine. Use the heart method. We're just practicing both ways this time. Even if you like that way better and you're going to pick that way, I want you to try this way for right now. Okay? So the 5 is going to go to the what, Faith? To the 10. And so if you did it with just arrows, you might have stopped right there. But if you did the heart method, come on around, that's really going to make it a weird looking heart. That's okay. 50. Mason, what about the 8? Yes. Okay. It would be 56. And you might have stopped and put your answer here and here. That is fine either way. The 56 is still over here. The 50 is still here. And we can see which one is larger. Okay? Now, after all this time, steal it and hide it, heart method. How many of you like steal it and hide it better? How many of you like heart method better? Yeah. Or you could change it to those little arrows. Either way. Pretty much after today, if you see a question that's asking you to compare fractions, you can choose either one of those that you like best. And that's the nice thing about having several different strategies. Okay? All right, so we're going to keep moving on. I feel like you guys are really comfortable with these two things, pretty much. Now, the thing is knowing when to use them. This is for comparing, knowing which one is larger or smaller. Go ahead and erase your board. And we're going to move on to practicing converting our improper fractions and mixed numbers just for a little bit. I just want to give you a few of these. Make sure we're still remembering what we did yesterday. I just felt like it was a lot to take in yesterday. It wasn't super hard. It was just a lot, you know? Huh?
So what did we do?
What did we do?
Yeah.
Don't ask that question. Okay, let me flip over to some practice problems. I will pretend I didn't do them.
Wait, bro, what are we doing?
You're fixing to remember, trust me.
We done the fractions. Wait, what?
Okay, I'm just dividing that up for myself.
Oh, we divided.
So if you had 12/5 and your directions were to, please take this fraction and write it as a mixed number. It's now coming back.
I know.
Okay. What would you just tell us with words real quick? What would we do here to get us going? What would we use, Reagan? You remember what it's called?
A number bond.
We would use a number bond, and we would try to pull out as many whole numbers as we could. And remember, a whole number, any number over itself is equal to 1. Cha cha cha.
Can we do it?
Get up. Let's do it. Here we go. Y'all repeat it. This is a repeat after me song.
This is repeat after me song.
Any number
Any number
over itself
over itself
is greater than 1.
greater
Oh, my
than
stars.
1.
That's wrong. Rewind. Blah, 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 blah. All right. Here we go. This is a repeat after me song.
This is a repeat after me song.
Any number
Any number
over itself
over itself
is equal to 1.
is equal to 1.
Cha cha cha.
Cha cha cha.
Okay. Greater than 1. Where did I even get that from? I don't know.
Oh, Miss Wendy.
Yeah, no, really. That's one of those things. It just happens. Okay, so we have this fraction. We're trying to, with our number bond, pull out one whole as many times as we can. What is one whole going to be when we have fifths? 5/5. So we're trying to pull out 5/5 as many times as we can, and then we see what piece we have left over. So let me let you try. See how far you can get with that, and then we'll check it. I realized that just a second ago. See, the more y'all do these, the faster you have gotten faster at this. So these just take some practice. All right, it's almost like division. You got to ask yourself, how many times can I pull 5 out of that? Since 5/5 is our one whole, how many times can I pull up 5 out of 12? Yeah. You're saying 2 times. Well, look, 3 times. Okay, listen to me, guys. 3 times would be 15. That's too many. I don't have 15/5. Because 5 times 3 is 15. I can only pull out as many as I have. So, that's weird. Okay. She's saying I can pull it out 2 times. Why? Because how many does that equal? How many does 5 and 5 equal? 10. If I take 10 away from 12, what do I have left?
Dose.
2. Okay. Yeah, dose. However we want to say it, we've got 2. 2 is not big enough to make 5/5, to make another whole. Okay, so it's like our remainder. It's like our leftovers. So this is one whole number, this is one whole number, and this is the leftover piece. So what does our mixed number become? Yeah. 2 and 2/5. You just add that little and in there. 2 and 2/5. It's almost like there's a little baby plus sign right there because they go together, you know, that you just don't see. It's 2 and 2/5. They go together.
I can't.
Okay. All right. Let's try another one. We won't do a ton of these, but probably of all 4 new things, the steal it and hide it, heart method, and then the improper mixed numbers stuff, that one probably was the toughest part of all of 4, and none of these are super difficult. It just takes practice.
I like them.
Okay.
Now I remember what we did.
Good. Okay. Let's go with 17/4. Okay. 17/4. So you gotta ask yourself, how many 4/4 can I pull out of there? How many times can I pull 4 out of 17/4? No, go ahead and write it down. Oh. That may come later. Okay. All right. Ishmael, help me out here. How many times can I pull 4/4 out? 4 times? Because 4 times 4 is what? 16. I'm trying to get as close to that as I can without being too big. So 4/4, 4/4, 4/4, 4/4. Yeah, 4 times is 16. If I pull 16 out, how many have I got left over? 1. So I've got to include that. I've got to put that 1/4 is left over. So we've got one whole number, another one, another one, another one. So what is our mixed number? What's it going to be? Go ahead and finish it off. 4 and 1/4. Okay? So that's how you'd write it as a mixed number. Now, just give me your eyes for a second. I told you yesterday, this is not for everybody. If you are not ready for this, that's fine. But if you recognize that that is 16/4 right there, okay? Let me do this real quick. You might have had a board that looked like this. You might also recognize, remember like forever ago, I told you the fraction symbol is actually a division symbol?
Yeah.
Okay, so that's like 16 divided by 4. Well, what does that equal to? 4 and the 1/4. Okay, and I have seen that showing up in a few places, so if that's where you're comfortable, that is fine to do. If you are more comfortable writing out every set of 4/4, do that, because that's what most of us are doing right now. Okay. Okay. Question about this? Did it kind of come back to you once we started doing it? Okay. So let's switch. What if you got asked to go the other direction?
Are we going to the right this time?
What if you were given 3 and 5/8? Now, I learned something else in second period that might help some of you. You might not need this, but this is what, remember how I told you to go, help me out here, you know? And we had the MA. What did the M stand for? What did the M to multiply? Okay, to multiply. The A stood for adding. Okay, well, Miss Terry saw us doing that, and she said, oh, well, in 5th grade, they don't say ma, they say mad. Let's get mad. And this is what they mean by that. Multiply, no. Multiply, and then add, and then put that number over the same denominator. And I like that because sometimes we multiply and we add, and then we have this number, and we're like, what do we do with that, you know? So, let me ask this in case somebody needs a reminder. What gets multiplied together? Reagan, what gets multiplied? What 2 numbers? The 8 and the 3 get multiplied. So what is 8 times 3, everybody?
24.
24. All right. Who knows what number we add? Yeah. We add that 5 because that's our little extra pieces, like our remainder. You know when we check our division problems with multiplication and then we have to add in the remainder to make sure we get the right answer? This is kind of what we're doing. So we add in the 5, and that will give us 29. Okay, so we have 29, but what do we do with that? We put it over the same denominator, right here. So we have 29 eighths. Okay? So if you can remember this by thinking ma, great. If you can remember this better by thinking mad, great. Okay? Whatever helps you. Whatever helps you. Let's do one more of these. Okay, please turn that into an improper fraction. And if this helps you, write this on your board beside it. I'm going to include that D today just to show us if it can help you. Multiply, you're going to add, and put it over the denominator. Got it? Okay. These become pretty quick once we get these. As long as the numbers aren't huge. Sometimes the numbers get really big and we've got to do some bigger multiplication. Okay. Will, what did you come up with for your final improper fraction? Anybody agree with 43 ninths? Okay. You got there, I'm assuming, by multiplying 9 times 4 and adding the 7. All right, 9 times 4 is 36. Plus 7 is the 43. And then we're going to put it over that denominator that we already have, 43 ninths. Probably do you have a question? Okay. Probably the thing I see the most with changing a number like this, a lot of times, guys, you'll get an answer to maybe we've multiplied our fractions or added our fractions, and maybe your answer is an improper fraction, and the directions will tell you, and I'll even tell you, okay, at the very end, when you get something like this, now change it to a mixed number. And that's where you would do the number bond, okay? Every now and then, you'll go the other direction and change it to a improper fraction. Sometimes you've got to change something to an improper fraction, do the math, and at the very end, you change it back into a mixed number. So it just depends on what we're doing with fractions. But these two things that we've just done, we will use a lot here and there with the rest of our fraction work. Okay. All right. I feel like I'm ready to let you go. That you've practiced enough to let you venture off into the big world. Fly out of the nest, little birds. Okay. Now, let me pause for a second. I need y'all to just chill for a second and hold on. Okay. If you're at home and you're working on this lesson, and this is a review lesson for what we did over the last 2 days, you have 2 worksheets attached to this lesson in Google Classroom. You cannot write or type in your answers. You'll have to write the problems on your own paper, work them out, and then bring that back to me when you return to school. Okay, so that is the end of our video here. and work hard on those worksheets.
That was